Okay guys, I'm gonna go over the study guide so then you can prep for the test. I will try to put basically all the answers on it, not all the work for all of them, so then you can go through and check your work or check your answers. Okay, for the first section, it is Pythagorean theorem. Pythagorean theorem we should really know by heart. It is when you have a right triangle, you know two outsides and you're trying to find a third outside. So it is a squared plus b squared equals c squared. The most important part about this is that c squared is the hypotenuse. The biggest side has to be by itself. You're adding the two short sides, the legs, so here the legs, and c is the hypotenuse. So if not, your equation will be wrong and then the whole problem will be wrong. We square all of them. What two are we gonna add? You can put a plus in the 90 to remind you. So it's 9 squared plus 17 squared equals x squared. Okay, then you do your math on the calculator, 9 times 9, 17 times 17, add those up, 81, and we get 370, and it equals x squared. And then from here, last step, how do you get x by itself? It has a little squared on it. Square root is the opposite. They cancel each other, and we get x by itself. So now we're done, and it equals the square root 370. And as a decimal, you can round it, and it's 19.2. So x is an estimate of 19.2. So it means, double check your work. Does it make sense that this side is 19.2? Yes, it's the hypotenuse. It should be the biggest side out of all three. One side is 9, one is 17, and then the last one is 19.2. Okay, number 3. We square all of them, Pythagorean theorem, and we add x. So this one is x squared plus 6.8 squared equals 8.1 squared. You just do your math. I'm honestly going to subtract 6.8 squared. That's how I want to do it, but you can also do it the other way where you multiply 6.8 times 6.8. So 8.1 squared minus 6.8 squared, and it equals 19.37. And then at the end, square root. X is close to 4.4. So it means this side is 4.4. Does that make sense? Yeah, it's not the hypotenuse, so it should be smaller. So yeah, it does make sense. Okay, for the word problems, do your best to read each word problem and complete it. It's still Pythagorean theorem, so it's a right triangle. An Olympic-sized swimming pool is approximately 50 meters long by 25 meters wide. Okay, a pool, it's probably a rectangle. You have 50 meters and 25. What distance will a swimmer travel if they swim from one corner to the opposite? So they're going from one corner to the other. They're basically telling you to take a rectangle and cut it in half so you get a right triangle. So we have this right triangle and we're finding x. So again, you set it up, square all of them, add the 50 and 25, and then complete your work. So this one I will not complete, but it's not bad to go through it. I will talk about the answers to the rest of them though. So for number 5, we should get x is an estimate of 55.9 meters. That's how far he's gonna swim. For number 2, you should get 8.7 as the decimal, but it's also square root 75, or when you take out pairs, we need to know how to do that, 5 radical 3. Okay, so I would really want to see all those 3 answers. Like you have this one, the simplified radical, and then sure, the decimal. And then square root 75 if you leave it. For number 4, x is an estimate of 12, no. Oh, okay. For this problem, okay, maybe I will do this one. This one, we can only do Pythagorean theorem on a right triangle. And if I kind of hide this stuff in the middle, is this triangle a right triangle? No, this is not a right angle. The right one is not a right angle, and the top one, we don't know if it's a right angle. So it's not a right triangle. So we need to do our math for the one that we do see as a right triangle, which is the one in the right. If you kind of write out your numbers, this is 13, this is 18, and we're missing the bottom. So what you're doing is you're finding how long it is from here to here, and then you're gonna have to double it. It's gonna turn into 2 pieces. So when you do that, your math should take you to, again, square them both, square them all, and add 13 and x, and then do your math. You should get that it equals 12.4 So you can call it y if you want, or call it x, whatever letter you want. And if you double it, then the real answer for x, like the whole thing, is 24.8. For number 6, we should get x is close to 6.2. All right, now let's talk about section 2. Section 2 is, these are not necessarily right triangles. We don't know. We're deciding if it's a right triangle, an acute triangle, or an obtuse triangle. Okay, hopefully we remember what those are. A right triangle is, it has a right angle. So it looks something like this. That's a right triangle. An acute triangle is something smaller, where all of them on the inside are less than 90 degrees. There is nothing inside that is more than 90. So it could be 80. It could be 82. And then the last one, if I do 180 minus 80 minus 82, it's 18. So this is an acute triangle where they're all less than 90. And an obtuse triangle is when one of them is bigger than 90, just one. So if you have 100 here and then you have 50, then this one's 30. They add up to 180 still, but one of them is bigger than 90. So that's obtuse, acute, and right. Okay, so for this, we still have to check with Pythagorean theorem. So it's going to be a squared plus b squared. If it's a right triangle, it is going to be equal to c squared. Okay, the hypotenuse. The hypotenuse will be equal to the legs. If it's an acute triangle, a squared plus b squared. If it's acute, it means that the hypotenuse is smaller. So how can I do smaller? Is it greater or less? Well, if the hypotenuse is smaller, it means it's eating the legs. So the legs are bigger. And for the last one, a squared plus b squared, if it's obtuse, that means the hypotenuse, the biggest side, is bigger. It's greater than the legs. Okay, so if you get one of those, that's how you know. So for each of these problems, you do have to remember this part though first before you even start a problem. You have to check if the two small sides are bigger, greater than the third side. So first you have to do that math. Is this a triangle? Do those numbers make a triangle? So we add the first two and we get 41. Is that bigger than 29? Yes, it is a triangle. So it's not option 1. So now that we know that it is a triangle, now we do this math. Now we do we check with Pythagorean theorem, even though it might be a right triangle or it might not. So 20 squared plus 21 squared, what is it compared to 29 squared? Do this in the calculator. I think you get 841. 29 times 29 is 841. And because they're the same, it's an equal sign. So it means it is a right triangle because we got an equal. They're equal. Okay, number 8, again, first stop and check. 5 plus 9, is that bigger than 10? Yes. It has enough room to be a triangle. So yes, it's a triangle. So it's not the first one, not a triangle. It's not that. Now we check what kind of triangle. 5 squared plus 9 squared. What is that compared to 10 squared? When you do your math, 5 times 5 plus 9 times 9 is 106. And 10 times 10 is 100. Okay, they're not equal, so it's not a right triangle, because if it had an equal sign, it would be right, but it's not. The acute sides are bigger. So what's going on with the hypotenuse? This is the hypotenuse side. This is the hypotenuse side. It is less, okay? It's less, so it's acute. All right, let's go through the back. On the back, again, stop and check first. Add the first two. 3 plus 15 is 18. Is that bigger than 18? No, that is the same as 18. So this is not a triangle. Those sides would not be able to close on a triangle. If I gave you something that measured like 3 inches, okay? 1, 2, 3. And then another one was 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, like that. And then you make a side that's 18, it will not be able to close. It probably is going to go past it, and that's not a triangle. So it just doesn't work, okay? It doesn't work. It's not a triangle because the two short ones are not bigger than the last one. So you just stop. You just say, hey, not a triangle. You showed me the work right here. No, not a triangle. Okay, so you should be able to do 10. Okay, after this, we get to the special triangles. So next topic is special right triangles. For a 45, 45, if we have two 45 degrees, we have two sides that are the same, these. So I'm just gonna put X. They could be 3s or 5s or 10s, whatever. And then the hypotenuse, it's gonna be X times radical 2. You take whatever number you multiply by radical 2. Okay, so for a 45 triangle, all you have to do is multiply by radical 2 or divide by radical 2. For a 30, 60, 90, that one, you have to multiply by two different things. For one side, you multiply by 2. For another side, you multiply by radical 3. There is no radical 2 on the 30, 60, 90. Okay, so for this one, if you know the smallest side, the one across from the 30. So here's the 30 degrees. If you know the smallest side, to get to the 90 side, so the 90 would be the hypotenuse. So to get to the hypotenuse, you multiply by 2. And to get to the side across from 60 degrees, you multiply by radical 3. And to go backwards, you just divide by radical 3 or divide by 2. Okay, so if we're on 11, if this is 5, then X is 5. And then we need to multiply by what? There's only one number we worry about, radical 2. We're trying to get to the hypotenuse. So we're going to multiply 5 by radical 2. 5 times radical 2. Okay, those cannot multiply. It's not 10. It's not radical 10. It's just 5 radical 2. And that's it. We're done. So this is 5 and this is 5 radical 2. Okay, no decimals on these. Okay, this is a 30, 60, 90. So we have the 30 degree and we have the smallest side. That's the best side to know. If you're going to the hypotenuse, so this way, because the hypotenuse is across from the 90, then you're going to multiply it by 2. So 9 times 2 is 18. And if you want to go to the 60 side, because this is 60 degrees, how do I know? Because I do 180 minus 30 minus 90, because we had a box and it makes 60 degrees. Okay, it's 60. We multiply by radical 3, so it's 9 radical 3. Okay, so X is 18 and Y is 9 radical 3. Okay, for this one, 30, 60, 90 again. This one's 30. We know the hypotenuse. So the one across from 30, this is the best side to know. And if you want to go to the hypotenuse, you multiply by 2. But if you know the answer on the hypotenuse, then to go back, divide by 2. 22 divided by 2 is 11. And then now you can jump to the X. You are not allowed to go from 22 to X. Like, there's no math that can take you there. You first have to go from 22 back to the 30, and then the 30 can take you to the 60. You multiply by radical 3, so it's 11 radical 3. And 11. Okay, I'll give you the answers for, okay, I'll show you this one. It's a 45, 45. These two sides are the same. We know the hypotenuse is 16, so that means we're not multiplying, we're dividing. What are we dividing by? Radical 2. That's the only thing you need to worry about. So we're going to take 16. How do I say divide? Fraction, radical 2. Okay, that is the answer for X and Y. But that's an improper answer because you're not allowed to have a radical on the bottom. So we're going to multiply by radical 2, the same thing that's on the bottom. Why do we do that? Because when you do radical 2 times radical 2, it's just 2. Or think about it. Radical 2 times radical 2, well, that's square root 4. Because 2 times 2 is 4 inside a square root. And then you can check in the calculator. What's the square root of 4? It's 2, right? Because there's two pairs of 2. There's two 2's inside. Okay, on the top, 16 times radical 2. That's just 16 times radical 2. They do not multiply to 32. No, they stay separate because one has a radical and one doesn't. Okay, that is the answer. You just have to double check. Is there anything that you can simplify? Okay, so I asked myself, are there pairs in the number radical 2? No. So that's fine. Is there a radical on the bottom? No. That's fine. But can I divide these two numbers, 16 and 2? Yes, because they both don't have radicals. So 16 divided by 2 is 8. Right? It goes to the top, the numerator, and at the top we still had radical 2. So this side is 8 radical 2, and this one is 8 radical 2. Okay, for these, I won't show the work, but I'll tell you the answers. You need to show me the work on a test or I will not give you full credit. So this one, 14 radical 3 and 28 radical 3. And this is 19 and 19. Okay, we are skipping 17 to 25. Sine, cosine, and tangent. Okay, it says remember. What are we remembering? We're remembering so, ka, to, a. What does that mean? It means if we have sine and you put a degree next to it, then it's going to be the opposite in the hypotenuse. If you have cosine and you put a degree next to it, then it's going to be adjacent in hypotenuse. And if you have tangent and you put a degree next to it, it's going to be opposite and adjacent. Okay, so for these, all you are doing is saying, like, right now you can already get the answer to tan. Okay, you can already get the answer to tan because this is tan Q. So it means if you start at Q, so I'm going to erase these things for now. If I'm at Q, let's say I'm in this corner, which one is the hypotenuse? The blank one. Which one is adjacent? It'd be 16 because H and A are next to each other. And 30 is the opposite. Okay, tan of Q means opposite in hypotenuse. So you put the opposite number on the top, 30, and the adjacent number on the bottom, 16. And that's the answer. It's 30 to 16. You can reduce it, but that's the answer. That's all you need to do, 30 to 16. So I'm going to come back over here, and tan is 30 to 16. Now, sine and cosine you cannot do. If I say sine of Q is opposite in hypotenuse. What's opposite to Q? 30. So the answer is 30 at the top. The hypotenuse is blank. So that's why you can't complete this problem until you find the missing side. So we need to find the hypotenuse. So how do we find a hypotenuse? When we know two outside numbers, Pythagorean theorem. So I'm just going to put x. Square them all. Square, square, square. Just like in the first 1 through 6 problems. And now we add. What do we add? The 30 and 16 on this one. It's not always that. 16 squared plus 30 squared equals x squared. Okay, put that in the calculator. 16 times 16 plus 30 times 30. 1156, and it equals x squared. Last step, how can x be by itself? Square root. Those cancel. You get x by itself. And the square root of 1156 is 34. So it means that this side is 34. Now I can do sine Q. If I'm at Q, it's opposite and hypotenuse. So it's 30 and 34. If it says cosine Q, okay, cosine Q is adjacent. What's next to Q? 16 and hypotenuse, 34. So it's 16 and 34. And now you're doing the same problem, but you're starting from a different corner. Sine R, cosine R, tan R. So now you are starting from the R corner. Sine is opposite and hypotenuse. So that's 16 and 34. Cosine R, if I'm at R, this is adjacent and that one's hypotenuse. So it's 30 to 34. And then tan from R, tan is opposite. So 16 first and adjacent 30. And that's it. All of these can reduce. There you go. Those are your answers. That's all you had to do. It's just, if they ask you for the trig ratio means a fraction. You already know the sides. We don't need the degree. They don't need you to find the degree. They just want the fraction. It does say simplest form, so you guys should be reducing these. So like 30 to 34 would reduce. They both divide by 2, and it's 15 to 17. And then you reduce all of them. Okay, now 427 on, now you're using those trig functions, sine, cosine, tangent, in your calculator. First, we label the triangle. We are starting from the corner where the 54 degrees is at. So these two sides are H and A. Which one's H? The one across from the 90. So that's H. This is A. And this one has to be O. We cross out the one that we don't want. We need the A because it has a 9. And we need the O because it has an X. We don't need H. So you can erase it, cross it out, whatever. Now, what trig function do you need to use? Which one has O and A? Tan. Tan of 54 degrees is equal to opposite, O on top, X, and A on the bottom, 9. And now you solve for x. How do I get x by itself? It says x divided by 9, so the opposite is to multiply by 9. And then I multiply by 9, so I keep it the same. Okay, what's left on the right? Just x, so you're done. And on the left, 9 times tan, 54. Okay, you type that into the calculator, only this part goes in the calculator, and it gives you an estimate. Make sure that your calculator is in degrees. X is close to 12.4. So it means that this side on the bottom measures 12.4. You complete them all like that. So I'll do one more. Okay, we start at 46 degrees. These two sides are H and A, H and A. Which one's H? The bottom. And A would be the blank one. And the one across from 46 is opposite because it's across. Okay, which one do I not need? A. A is not useful. So which one uses O and H? That would be, out of these three right here, sine. So I have to use sine. Sine of 46 degrees equals opposite, 24, and hypotenuse is on the bottom, so x. See, this problem is different because x is on the bottom. Okay, how do I solve this? It's up to you how you want to solve it. There's many ways to do it. I'm going to show you one. How do I get x by itself? It says 24 divided by x, so the opposite is to multiply by x. And then I multiply by x. So I have left x is multiplying with sine 46, and it equals 24. Okay, last step. Now x is on the left. How do I get x by itself? Well, it's multiplying with sine, so the opposite of multiplying is to divide. So I'm going to divide by sine 46, and it cancels to 1, and divide this one by sine 46. So now what's left? X is by itself, so I'm done. And it equals 24 and sine 46. I type this in the calculator, and I get an estimate. Make sure you use a fraction or you divide. 24 divided by sine 46. And it equals, x is close to 33.4. So it means that this side right here is 33.4. Does that make sense? Does that answer make sense? Yes, this is the hypotenuse. It should be bigger than 24, and it is. For my last problem, we got 12.4. Yeah, it's fine. All right, so for the rest of these, I don't think I will do them. You should be able to complete them, but I can tell you the answer, or maybe I'll show you one of the inverses. So for 29, x is close to 25.5. For 30, x is close to 17.2. Okay, for 31, I'll do it because now x is on the inside. So same thing, label your triangle. This is where the degree is, so H and A. Which one's H? 24. This one's A, and this is O. Okay, we don't want A. Which one uses O and H only? That would be sine. Sine, you put the degree. Well, the degree is x because we don't know it. And it equals opposite, 23 to 24. Now, x has to be by itself. It's not multiplying with sine, it is a part of sine. So they need to swap places. We need to use sine inverse. Sine inverse, and now they swap places, 23 to 24, and it equals x. Now x is by itself. You put it in the calculator, you press the blue button first to get sine -1. 23 divided by 24, oh my gosh. 23 divided by 24. Make sure your calculator's in degrees, and I get x is equal to 73.4 degrees. Now it is a degree. So that's how you would complete the rest of those. So for 32, x is equal to 37.6 degrees. X is equal to 50.3 degrees. X is equal to 19.2 degrees. All right. And now we complete these. Basically, the word problems are literally this. You should be drawing right triangles. If it says elevation, you want to draw it. So if we read through the problem, it does say elevation. If we read through 36, it says elevation. Okay, when it says elevation, it means that you have a right triangle. So there's only two ways you draw a triangle. Elevation is like this, because the 90 is on the bottom and the degree goes in the corner. An angle of depression is when the 90 is at the top and the degrees at the top. So like that. Okay, elevation, these two, and this is depression. All right. So you want to draw a right triangle, and then you just put everything where it goes. If the 90 is at the bottom, the degree is on the bottom, so 24 degrees. Katie is sitting 36 feet from the base of the screen. The base means the bottom, so 36 goes on the bottom. And it says, how tall is the movie screen? So you're finding x. So it's going to be the same math as here, like sine, cosine, tan, inverse, all that. Okay, you should be able to complete this one. So I'll tell you the answers for these. You should get 16 feet, exactly. For this one, x is similar to 159.1 feet. Okay, complete your problems. Make sure you draw it. Show your work on a test. Okay, more triangles that you're drawing. Make sure you read through them. X is similar to 850.9 feet. X is close to 4809.2 feet. And this one, x, is similar to 11.7 degrees. This one is a degree because it says find the angle. So x should be on the inside, not the outside. Okay, we're almost done. Law of sine. Okay, law of sine and law of cosine are different. Law of sine is when we do those two fractions, when we do those two proportions, and you're finding opposite, because the sine is opposite. Okay, you know that you're using law of sine on this one because it has 2 degrees. So 27 degrees goes with the number 5. These are together. And 34 degrees goes with the bottom side, but it's blank. There's nothing there. And this corner goes with x. So to be honest, I don't really need the 34. I do need it a little bit. I need it because I need to find how many degrees the obtuse angle is. So how do I know how many degrees are in a triangle? 180. We should know that. If you subtract 34 degrees and you subtract 27 degrees, it'll tell you how many degrees goes into the obtuse. So 180 minus 34 minus 27, and it makes 119 degrees. Now we don't need the 34. Now the 34 is useless. Okay, so for this one, you need 119 and it goes with x, and you need 27 and it goes with 5. So now we're going to do sine of 27 degrees, and that one goes with 5, and sine of 119, and that one goes with x. And you just solve for x. You could have written x at the top and 5 on the top and the signs on the bottom, and that would have been faster. So for me, I am going to flip them. I'm going to flip this one, but whatever I do to one side, I got to do it to the other. So I'm going to flip this one as well. So now it's going to be 5 sine 27, x sine 119. How do I get x by itself? X is on the right. It says x divides sine 119. So opposite of dividing is to multiply by sine 119. These cancel to 1. And then I got to multiply this side by sine 119. Okay, when you multiply by sine 119, it is over 1. So you multiply top with top and bottom with bottom. Okay, so that means that the 5 is going to multiply with sine 119. And on the bottom, 1 times sine 27 is just sine 27. And what does it equal on this side? Well, the signs cancel, so just x. So you're done. This goes in the calculator. Make sure you press the green button and the one next to it to get those 2 boxes, so you can type it in and get a decimal. X is similar to 9.6. Okay, you do 41 the same way. X, well, this one's reversed now that I think about it. So let's talk about this one. Okay, x should go with 17, and 92 should go with 35. So luckily we don't need this angle, we don't need it. So now I'm going to put sine of x, that's the degree, and it goes with 17. And then sine of 92 degrees, and it goes with 35. Solve for x. Okay, x is on this side. First we move the 17. It says divide, so you multiply. And it's going to multiply to the top. So now you have left sine of x degrees. I like to put the 17 to the front. 17 times sine of 92 and 35. Now, how do you get x by itself? It is not multiplying by sine, it is a part of sine. So you need to do sine inverse. We are going to switch with everything on the right. So now it's going to be sine inverse all of that switches, 17 sine 92 over 35, okay, sine inverse and regular sine, and it equals x. So now x is by itself, all of this goes in the calculator. And it should be x, whoa, x is similar to 29 degrees. For this one, again, it's a sine problem, law of sine problem, so you're going to be drawing like something similar. It says a 20-foot flagpole is leaning towards a house. So there's a flagpole, but I guess it's falling towards a house. The flagpole makes an 85-degree angle with the ground. There's 85 degrees. So this is the flagpole. So this is the flag. And the angle of elevation from the base of the house to the top of the flagpole, so it means like when you elevate it, when it connects, it's 55 degrees. Find the distance from the base of the pole to the base of the house, so you're finding here. All right, so if that's what I'm finding, oh yeah, and then the flag is 20. So don't forget the flagpole is 20. That was at the beginning of the problem. So if you're finding this part, I'm gonna erase the little flag. We need to know how many degrees the top corner is. You need to know it because it's the pair of x. So again, 180 minus 85 degrees minus 55, and you should get 40. And now you can do the law of sine, where you make your two fractions, right? Sine 40 is with x, and then we need sine 55 with 20. We don't need the 85 anymore. And then you solve for x. So you can flip them and then multiply, and then you'll be good. And you should get x is similar to 15.7 feet. Okay, now law of cosine. Law of cosine is an equation very different than law of sine, not two fractions, not proportions. Okay, when do you know to use law of cosine? When you have 1 degree. So for this one, don't forget, it is 3 separate equations, but I just kept using the first one, A, the one with A, because wherever I see X, these two I'm gonna call capital A and lower a, and then B and C don't matter. Capital A is the degree. This is A, because the degree is 73 degrees. Little a is X. And then B you can put wherever. This corner is B, the degree. This one is little b because it's across from it. This one is big C, the degree, and this one is little c. Okay, the equation is a squared equals b squared plus c squared minus 2bc times cosine a. And all you do is plug everything in. Like literally you just plug it in. So a, which one's little a? That's x. So it's x squared. And then equals b, little b, 27 squared, plus little c, 22 squared, minus 2, b, c. So that's 27 and 22. And then cosine capital A is 73 degrees. Capital A is 73 degrees. And then now from here, you're really just solving for x. The nice thing about this problem is x is already by itself on the right. So this is a number. A number times a number plus a number times a number minus a number times a number times a number. Cosine 73 is just a number. All of these are numbers. So it means if you plug it into the calculator, it's fine. There is no x on that side. There's no y. There's no variable. So you can just plug all of this into the calculator and get one number instead of all of those. So I'm going to type 27 squared plus 22 squared minus 2 times 27 times 22 times cosine 73. Literally all of it. And it says x squared equals 865.662448. And now last step, what do I do? How to get x by itself? Square root. And I get x is similar. Second, x squared. Click the up arrow, enter, and you get 29.4. So that means that this side is 29.4. Okay, that's how you do all of them. Again, it's the best if you put a here. So I'm going to put capital A here. That's the degree, little a. And then B doesn't matter, or C. And then you can use the same equation again. Same thing for this one. If this is x, I'm going to call this one capital A and this one little a. And then b could be here, little b, and c, little c. And then now you set it up the same way. A squared equals b squared plus c squared minus 2 bc times cosine A. Set everything up. Little a is 11. 11 squared minus b, no, equals. Plus 17 squared minus 2, 10, 17, b and c. And then times cosine, what's capital A? Capital A is x now. Okay, on this problem, this one's different. X is over here. You cannot just put all of this in the calculator and get a number. It doesn't work because you have an x. So you're going to have to do it in parts. 11 times 11, 121. 10 times 10, 100. Plus 17 squared, 289. Plus 100. So I'm going to erase this part. When you put this in the calculator, it turns into 389 minus 2 times 10 times 17 minus 340, and then cosine x. Okay, can you subtract these two numbers first? No, you cannot. You cannot do that math. It doesn't work because think of a simpler example. If this number was a 5 minus, and this number was a 3, and then it's multiplying by a 2. Do you get the same answer if you subtract and then multiply, or if you multiply then subtract? No, you get different answers. So that's why you're not allowed to do that. Let's bring it all back. All right, so instead we need to get x by itself. How do I get x by itself? Move everything to the left. Which one goes first? The 389. It is a positive, so you got to subtract. So 121 minus 389, you get negative 268, and it equals negative 340 cosine x. Okay, now how do you get x by itself? Well, you need to move 340. How do you move it? Do you add it or do you divide it? We should be dividing it because it's multiplying. It's negative 340 multiplying with cosine. So you're going to divide by negative 340, divide by negative 340. So now we get cosine x, and on this side, two negatives cancel, so it's just 268 and 340. You can reduce the fraction or leave it. Now, how do you make x be separate from the cosine? Do you divide it? No. Cosine and x are not multiplying, they're a part of each other. So the only way they can separate is if they switch spots with what's on the other side of the equal sign. And that's with the reversal of it. So cosine inverse can switch now with 268 and 340, and then x switches. X is by itself, so this goes in the calculator, and that's how you get your answer. Okay, so the answer should be x is similar to 38 degrees. Same thing, this is going to be a cosine, law of cosine problem, so it's going to be like a weird looking triangle. I'll show you what it looks like. A utility pole is supported by two wires, one on each side going to the opposite direction. Okay, if the wires are 12 and 16 long and secured to the ground, find the distance between the wires and the ground. So what it's saying is there's a pole in the middle, and we don't really care about the pole. But then there's a wire that goes from the top to the ground, and there's another wire that goes from the top to the ground. We want to know how far apart the wires are, so we really don't care about the pole. Okay, one of the wires is 12, the other wire is 16, and then they form a 75-degree angle at the pole. So this is 75 degrees, and you're finding x. So again, law of cosine, just like how those other problems are. The answer to 44 is x is equal to 13.5. That's what you should have gotten. For this one, we should get x is equal to 17.3 meters. All right, for these, you're using the law of sine or the law of cosine. Why? Because they are not right triangles. If not, maybe we could have done like something else. So how do you know what you're doing? This one should be law of cosine because you don't have degrees. This is law of sine because you have 2 degrees. So you're just setting them up. You guys are finding all the angles. Okay, so basically put x in a corner here. These two, you can relabel them as A if you want or not. And then you're going to set up your equation. it is 6 squared equals 13 squared plus 11 squared minus 2, 13, 11, and then cosine of x. Then you do your math. You find x. Okay, once you do that math, you got to start over. Or I guess I'll show you. Okay, 36. 13 squared plus 11 squared.
Are you in here?
Yeah.
She's hiding.
Hey,
What are you doing? Hiding?
nothing.